If you could only learn 3 AI-related things this year, what would they be? Most developers can't answer that clearly, and that's a problem. When you can't answer it, you default to learning whatever shows up in your feed, or whatever's trending, whatever some roadmap told you to learn. And most of that won't matter in 12 months. I spend a lot of time thinking about which AI skills actually hold up and which ones just feel productive. This video is what I came up with. What counts as an AI skill? Let's start with that term AI skills because it's everywhere right now and it means almost nothing. LinkedIn is full of it. Job postings are full of it. Half the time it just means can use ChatGPT. The other half it means something vaguely related to machine learning that the person writing the post doesn't fully understand either. So the way I think about it is this. An AI skill is something that helps you build, ship, or maintain software that relies on AI to work. That's it. If it doesn't connect to something you're building or responsible for, it's not a skill, it's trivia. And a good filter for this, if the skill still helps you when the model changes, when the provider changes, when the hype dies down, it's probably real. But if it only works with one specific tool in one specific moment, then it's not a skill, it's a dependency. So what's wasting your time? And this might be an uncomfortable part for many people. These are things I think a lot of developers are over-investing in right now. The first one is prompt engineering as a standalone skill. I know this will bother people, but hear me out. Prompting matters, obviously. You need to know how to write good instructions for a module. But the way it's being taught right now as this isolated craft with libraries and templates and entire courses dedicated just to prompts, that's not going to age well. Models are getting better at understanding vague inputs. The tricks that work today, the specific phrasings, the chain of thought hacks, those things change every time a new model drops. Every time. What doesn't change is understanding why a prompt failed in the context of your system. That's useful. Memorizing a prompt template is not. Next is agent frameworks. Agents are genuinely interesting, and I'm not dismissing the concept, but a lot of developers are spending serious time learning specific agent frameworks. LangGraph, AutoGPT style orchestration, complex multi-agent setups, and they haven't shipped a basic LLM feature yet. Most production AI systems right now are not autonomous agents, they're controlled workflows with AI steps inside them. That's what most companies actually need, not a self-direction agent that decides what to do on its own. Not yet, at least. So if you're learning agent frameworks as your entry point into agent engineering, you're learning a very specific abstraction layer that's probably going to change dramatically. The pattern of agent matters, the frameworks don't. Thank you. Another skill you shouldn't over-invest your time in this year is fine-tuning. Fine-tuning feels like a real engineering skill, and it is in context, but for most teams, most of the time, it's not the right first move. If you haven't tried better prompts, retrieval augmented generation, or just giving the model better inputs, you're skipping several cheaper, faster, more maintainable skills and steps. Fine-tuning is high effort, high maintenance, and the model you fine-tune today might be obsolete in 3 months when a better base model comes out. Learn it eventually, but if you're spending this year with fine-tuning as your main AI skill, you're optimizing the wrong layer. And then vendor locking. If your main AI skill is learning the ins and outs of one specific provider's API, you're fragile. APIs change, pricing changes, models rotate, new providers show up. What survives is knowing how to think about model integration at the design level, provider agnostic thinking, abstraction layers that let you swap things out. That's engineering. The rest is just documentation you can look up. And this is the point where we get to the skills that actually compound. So what should you actually spend time on as an AI engineer or someone who's interested in AI this year? Well, the first one is retrieval augmented generation, RAG. And I mean real RAG, not demo RAG. There are several developers who have built a RAG demo. You take some documents, chunk them, embed them, stick them in a vector database, ask questions, and you're happy. Cool. That's the tutorial version. Production RAG is completely different problem. It's a completely different problem because you're dealing with chunking strategies that actually matter. How big should your chunk be? Do you overlap them? How do you handle tables and structured data inside documents? Then retrieval quality. Your model is only as good as what you retrieve. If you're pulling back irrelevant chunks, it doesn't matter how smart the model is. It's garbage in, garbage out. And evaluation is important too. How do you know your RAG system is actually working? How do you catch regressions when you change the prompt or switch modules? Most teams don't have good answers to these questions, so if you do, you're valuable. Back to evaluation, and here we'll introduce feedback loops. This is the skill almost nobody talks about, but almost everyone needs. You're running an AI system in production. You need to know if it's working. Sounds obvious, but it's genuinely hard. LLM outputs are non-deterministic, so you can't write a simple unit test that says the output should be exactly this. So you need evaluation frameworks. You need data sets that represent what good looks like. You need to measure quality over time, and you need to catch it when a model update or a prompt change breaks something. Boring foundation work, and it's where most AI systems fail in production. So if you get good at this, you'll be solving problems most teams don't even know they have yet. Another very important skill is cost, latency, and reliability. This is where AI meets real software engineering. In production, you care about things like, when do I use a smaller, cheaper module instead of the expensive one? How do I cache responses so I'm not making the same expensive call over and over? Do I stream the response or wait for the full thing? What happens when the API goes down? And it will go down. These are not glamorous skills, but they are the difference between an AI feature that works in a demo and one that works at scale. Knowing when to use Haiku instead of Opus, or 4.0 Mini instead of 4.0, or Gemini instead of OpenAI, or DeepSeek instead of Claude. That's real money saved, real latency saved. You also need to learn about constrained workflows. This is where the agent concept actually becomes useful, not really as an autonomous system here, but more as a bounded supervised process. AWS, Google Cloud, Azure, they're all building agent-style products. Manage AI workflows. Understanding how to build workflows where AI does specific things under specific constraints is a real skill. The keyword here is constraints. The valuable thing is not building an agent that can do everything. It's building a system where AI does the right thing reliably within boundaries you've defined. And the last one, knowing when AI should not be used. Sounds weird in the video about AI skills, but this might be the most important one. If you have deterministic logic, something you can solve with a regular function or a database query, putting an LLM in the middle of it adds cost, latency, and unpredictability for no reason. If you're in a compliance-sensitive area where you need exact auditable outputs, a probabilistic module is the wrong tool. If your users need to trust the output completely and you can't verify it, that's a problem. The engineers who understand these boundaries are the ones who will be making good architectural decisions. That matters more than knowing every AI tool on the market. Okay, now that we're done with that, let's talk about things worth watching. Some newer developments I think are directionally important. The first is MCP and agent skills. You've probably heard a lot about MCP by now, the Model Context Protocol. Anthropic launched it in late 2024, and for most of 2025 it was everywhere. That was last year where every AI influencer was talking about MCP servers. Every tool was rushing to add support. OpenAI adopted it, Google adopted it, got donated to the Linux Foundation. And by the numbers it won, it's the standard. But by late last year, developers who actually tried to build with MCP started asking reasonable questions. October last year, Anthropic launched agent skills, and this matters for your learning priorities. Skills are simple folders with markdown files and optional scripts. No server or protocol layer, no infrastructure to manage. You write instructions that teach an AI agent how to approach a specific task, and it follows them when they're relevant. The creator of Flask wrote about moving all his MCP integrations into skills, and they actually performed better. So the way to think about it is MCP gives an AI agent access to external systems, databases, APIs, cloud services, and skills teach the agent what to do with that access. MCP is the connection, skills are the knowledge. And for most developers right now, skills are more practical, simpler to build, faster to iterate on without any infrastructure overhead. If you need your AI agent to connect to something it can't reach otherwise, that's MCP. But if you're teaching an agent how to follow your team's coding conventions, how to analyze data a certain way, how to generate a report in your company's format, that's a skill. Don't spend months learning to build MCP servers unless you have a specific integration problem that needs one. If you want to get effective in AI tooling in 2026, learn how to write good skills. That's where the practical value is right now. Also, llms.txt, something to watch. The basic idea is that websites and services can publish a file similar to robots.txt that tells AI modules what the site is about and how to interact with it. The underlying idea is welcome, very important too. So here's a simple filter you can use to decide what parts of the AI hype you should spend your time on. When you're deciding whether to spend time learning something AI related, ask yourself 3 questions. Will this still matter if the model changes? If it's tied to a specific model's quirks or a specific version of an API, then it's fragile. Does this help me ship something real? If you can't connect it to a product, a feature, a system you're responsible for, then it's theoretical. You also ask, does this reduce uncertainty or does it just add options? A lot of AI learning feels productive because it gives you more things you could do, but what you actually need is fewer, better decisions. So focus on the skills that help you make those. 2026 is not a year to learn everything about AI. It's a year to learn the right things. The novelty phase has ended. 2 years ago, just knowing what an LLM was made you interesting in meetings. Well, that's over. Companies have past curiosity. They want people who can build things that work, maintain them when they break, and make good calls about when AI is the right solution and when it isn't. So if you're feeling overwhelmed by all the AI content out there, all the roadmaps, all the courses, all the you need to learn this now energy, just take a breath. Most of it won't matter anyway. So focus on the stuff that compounds. Build things, break them. Pay attention to what actually works. That's the important skill right now. Please hit the like button on this video if you like it. Hit the subscribe button if you want to see more content like this. I want to hear from you in the comments. Did this video help you in any way? And what AI skills are you planning to learn this year?